Okay, my name is George. I work as a lead consultant for Redify, and this presentation is going to be about option types. Who has used option types before? Anybody? Yeah? 2? 3? Yes. So, we will give a quick introduction to why non-reference exceptions are happening in C#, why they are so used. We are so used to see them. Then we will see why option types are there in F# and which type of problem they are solving. Then how to consume them using pattern matching. So we will learn the basics of that. And then we will see 2 more ways of using option types, or how to handle or managing option types by using the map and bind functions. And if this is your first time working with option types, the 2 last ones are going to be a bit tough, so don't worry much about them. Just pay more attention about the first part of the talk, but maybe you could get some value from that as well. So if you see that method, that's C#, it's not even F# yet. Can you tell me if that's going to be, that customer could be null or not?
Could be.
It could be, yeah. It's hard to tell, yes, because if you go and check how is the signature of the method, it's saying that it will return a customer. But it's not actually telling you if that could be null or not. You could assume that if the 42 ID customer doesn't exist, could throw an exception, or could return a null object. So whenever I try to consume that customer, and I want to access, in this case, the property edge, I could get a NullReference exception if that was the case. So now my code should look like this. Yes, I need to go and check if the customer that I got was null, just in case, and in that case I will throw an exception, or I could do something else if that was the case. Yes. So what that means is that from now on, in every single place where an object is returned, I need to check if that was a null or not. Yeah? And you could go and say, okay, that means that maybe half of the code base now should check for nulls. That's not very pragmatic, so what we tend to do is to say, okay, no, I am pretty sure that this doesn't return a null, so I don't need to check for every single case.
There's kind of pattern called null design pattern, but it's return null object, which is not null,
yeah.
It's like empty fields or
yeah. And that's pretty much what F#, or the way that F# tries to solve that. So in this case, you need to check, and because we don't want to check in any single place, what we tend to do is to guess. Yes, and whenever we guess, we could be wrong. And there's where we start getting non-reference exceptions in places where we didn't expect to get a null. Now, let's think we need to get the edge in this case, and not the customer. So the edge straight from that method. If we check the signature, now we get an integer. Could we get a null there? Not really. So I could go and use that edge without any problems, and I could use any property or method that that edge has, because I know it's never going to be a null object. But now you could say, okay, what I should return if there is no customer for that ID. Yeah. In the old days, what we were doing is returning 0 or -1, any magic value that we could then handle on the other side and be able to do exactly the same type of code that we were doing before. But in C#, those 2.0, we get nullable types. And the first thing that we thought is that, oh, now we get nulls with integers as well, so we will have the same problem.
We will check for has value.
Yeah. So that's the trick. The first thing to notice is that you won't use nullable types everywhere. Yeah, it's not the default. You would, because now you have 2 ways of representing that integer. You will use integers whenever you know that you will have a value, and for those exceptions in which you know that could be empty, you will use nullable types. So what that means is that now, instead of using age, I need to use age.value. And that gives me an indication that that could be null. Yeah? And therefore, I need to check now for that. And again, this code looks similar to the previous code, but now these are exceptions. If you think about how many times you have null-reference exceptions or similar type of exceptions using nullable types, almost never, because you don't use them. You use integer, and only those ones when you really are sure that that could be a possibility, and therefore the consumer now needs to handle that scenario because it's a possible scenario, and it's fine to write that code in that case. The problem is when you miss it, or where you write it everywhere and it doesn't make sense. So in C# we have integers. We have nullable integers. We have reference types like customer, but we don't have nullable customers. So the same type customer is useful for both things, for whenever you have a value and whenever you don't have a value. In F# you have the integer, you have an option that is similar to the nullable, you have a customer that could be a reference type as well, and you have an option of customer. So in that case, you know that whenever you return a customer, it's always going to be a customer, and never is going to be an empty customer. Whenever you use an option, you get two different types. It's like inheritance. Think as option of int being the abstract, and then you have the implementation that could be none, or sum of int. That means that option is like a box that you need to open, and inside could be empty, having none, or it could be sum of int. And the same for a reference type like customer. You could get none or sum of customer. So let's analyze. Troy already showed how functions are in F#. Just a quick review. The first thing that you see there is a function name. We use lowercase in F# for function names. Then you have the parameters. Then they have the body function there. And then you have the value that we return. We don't use a return keyword because the last expression that gets evaluated in the function is what we actually return. The signature or type of this function is actually what you see there, and means int to int to int, where the first two ones are the ones that are the input parameters, and the last one is the value that we return. And you could think this as whenever you have a lambda expression that receives two integers and returns another integer, is a func of 3 ints. Well, that is pretty similar to that. And what we really want to do is to change this function to allow us to pass options. Yeah? So this is basically adding two numbers, and now we want to extend this to receive options as an exercise so we could see how the code is changing. So the current version of sum receives two integers and returns another integer. What we want is the possibility of sending two sum of those integers and returning another sum of that. And in the case that we send none as one of the parameters, we would expect to get a result of none. Okay? And again, this is using integers just to keep it simple, but this also applies for reference types like records in F# if you have used them. So we said we had this function, and that function is exactly the same as the one that you saw before. It's exactly the same that Troy was showing before. It's just that because you don't need to calculate the intermediate result, you get everything in just one line. You have the same signature. And now let's think how we could take one of the parameters and make it optional. Yeah, let's start with just one of the parameters. The thing that any C# developer will do is to go there and be explicit about the type. In the code that you see before here, you don't see any types because F# is inferring the types for you. But in this case, what you do is you are explicit, and we use brackets there to just wrap that this is, like in mathematics, this is a parameter, and the type of this parameter is an option. So in that sense, now what you could do is to check if this number is none, and we use just single equals in F# to do comparison, then what we do is to return 0. If that's not the case, we take the value from that num1 and we add it to num2. Num2 still is an integer. So the signature of this one is, the first one is an option of integer, the second one is still an integer, and what this returns is either 0 or the addition of those two numbers. So this is still an integer. But in F#, you don't really even need to do that. You don't need to be explicit about the type. Because by checking that against none, you are giving the compiler the hint that num1 is actually not an integer. It's an option. So automatically, the signature will still be an option, although you haven't defined that in the argument. And the good way of doing that is not using if, but using pattern matching. And what we are doing here is basically matching the argument num against two patterns that we have here. The first pattern is none, that is exactly the same that we had there. And if that's the case, if this matches with this pattern, we will return 0. Otherwise, we expect to have some, because that was the only other case. And by putting this val1 next to this, any name that you put there, is going to decompose the option, and it's going to put the value that was inside the option inside value 1. So now I could use value 1 in this side and add it to num1. That is still an integer. It's not an option yet. Yes? Any questions so far? Good. So far what we have is just the first argument being an option. And we want to go a bit further. We want to be able to return an option. Still, we won't touch the second argument. This is going to still be integer. That's going to be the next step. But now what we are changing is that if you see the signature right there, we have an integer that is an option, an integer that is not an option, and what we return is an option. And the compiler knows about that because instead of returning 0, in case of none, we will return none. Yeah, because there doesn't make sense to do the computation. If one of them is done, we will return none. And because we are returning none, now we need to be consistent with the type that we return. And if we do have a value for num1, now we need to return some of that computation. So we wrap the computation inside a sum object. And therefore, we have an option as a result. That's exactly the code that you saw there. Let's go even further. This is actually using two pattern matching. And what we have here is now, before we were assuming that num2 was an integer, now we are actually, once we evaluate the number 1, we evaluate number 2 now, and pattern match that second argument against these two patterns, and doing exactly that. So what we have here is 3 different output points. Yes, the first one is in the case that number 1 is none, the second one in case the number 2 is none, and the third one is going to be, okay, if none of them is none, we could do actually the addition, perform the addition. So let's go and write a bit of code so you get your mind around that, because I know that it's hard at the beginning to understand this. So let's create a sum that receives 2 arguments, and then we will do the sum like this. Okay, this is exactly the code that you saw before, and I could get the result by calling sum 1 and 2, and this is going to be evaluating. So whenever I click Alt Enter, whatever I have here gets evaluated on that side. So the first line that I evaluated was the definition of the sum, and you could see that the signature or the type is actually 3 integers, and then whenever I perform the action, I get the result that is also an integer, in this case 3. So let's transform this to be an option. So I said before that I could be like this and say, okay, this is an int option. And by doing that, you could see that this is actually complaining, saying that it won't be able to add an option and an integer. So, but I could even just, by checking if this is none, then 0, else and 1.value is that's going to do the same trick. And now if I need to call this, it's complaining that this is not actually an option, so I need to wrap this around and say this is sum of 1. So if I execute this, you could see here that now this argument is an option. If I execute that, it's going to still return 3. So now what I could do is to use pattern matching here. So I will match n1 with, and I will use none. And in that case, I could return 0, but we could go even further and say, okay, in that case, I want to return an option type. And if I get the sum of a value 1, then let's return sum. And inside here, we will say val1 plus n2. So I could remove this code. And if I execute this, you see that now the output of this function is actually an option. The first argument is an option, but still the second one is not. So now I could run the same code as before. I should get exactly the same result as before, but now it's wrapped inside sum. So the result is 3 wrapped inside an option type. And if I go and write none here, what I would get is a none. Yes, because one of the parameters is missing, so I cannot do the computation. So the next step is to convert the second one, this one, as an option. So in order to do that, I could again come here and be explicit about that, or I could just assume in my code that number 2 is actually an option as well. So what I will do is, if this is true, what I will do is to match n2 now with, and in this case I will match it with none. If that's the case, that's going to be none. And if this is not the case, this is going to be sum of value 2. And now what I will do is to add up value 1 with value 2. So if I execute this, you get now the 2 parameters plus the return value are option. Now it is complaining that this should not be an integer, so what I could do is sum1, sum2, and this is going to give me sum3, and if I specify none in any of them, I will get none. So this is the first version of the code. This is actually a good way to see the flow, but it could get quite messy, as you can imagine, because it's like having case, a switch in C#, so you have many of them, and in most of the cases it's very powerful, and actually pattern matching is much more than what you see here. It's much more powerful, but for these specific scenarios, you could go even further and improve this code a bit more. So let's see how we could do that. For that, we could use a function that is called option.map. And you could think of as map as the select that we have in C#. But in this case, it's not for, we tend to use select just for collections. In this case, we are not talking about the collection. We are talking about just a type that is an option. It's like having nullable type.select, something like that. So if you see the signature of that or the type of that function, it has two parameters. The first parameter, that's a lambda expression or another function that will receive a type A. That symbol like that, it means that it's a type A, and will return a type B. We don't really know which types are going to be. We are being generic here. The second argument is going to be an option of A, and the return value is going to be an option of B. So let's analyze what this guy is doing. He's asking me to pass a lambda expression that will do some computation, and the argument that I expect to have here, I could pass it as an option type. So I will pass sum1, and then I will pass the lambda expression. And what is going to happen is that this guy is going to evaluate. If what I pass here has a value, it will extract that value from the option. It will pass it here. It will compute the result, and it will return. It will wrap the result inside an option type. Okay? So what it's doing for me is the if condition or the pattern matching. Yeah. Only is going to call this if it has some of that integer. If I am passing a none, like in this case, it will return none. It won't bother trying to execute this because you haven't passed a valid argument that he could use. So we will go back a bit to the version that had only one of the two parameters as option. That is this one. So in this case, we are not having both pattern matchings, just one of them. So we are assuming that the only one that could be option is number one. Another way to write exactly that code is like you see there. So what we are doing here is using option.map, passing whatever we want to do inside there, and then as the second argument, passing what is number one. In that case, what we are doing is checking. So what option.map will do is, okay, is number one none? If that's the case, it's not going to execute that, and it will return none immediately. Otherwise, it will execute that. And by using the pipelining operator that Jorge was talking about, you could write the same thing in this way. So what the pipeline operator is doing here is taking whatever is on the left side and passing that at the end of the function. Yeah, so these two lines of code are exactly the same, just that sometimes it's easier to write things using the pipeline operator. And you could think the pipeline operator as if it were the extension methods in C#, whenever you use, like, you specify the first argument as this, and this converts the argument as being the outsider, or the one that contains that function. But then when you call it, what the compiler is doing is moving whatever is outside or on the left side of the dot as the first argument. Well, in this case, the compiler is moving whatever is on the left side of the pipeline operator as the last argument of the function, so it reads much more nicely.
Question just back on that. Oh, now I'm working the slides.
Yeah.
Would there be a way that you could use the pipeline operator to pass in the lambda expression to option.map?
No, because this only works for the last argument. Yeah. What you could do, if you need, and sometimes you do need that, most of the time you will find that the functions in F# are thought. So the thing that is the one that you will pass around between, because in this example, maybe it doesn't make much sense. Those lines of code look kind of the same, but whenever you need to compute this number one and process that or pass that through different functions is where this is useful, because you just write pipeline and then you write the next function and then another pipeline and the next function, and number one is passing around. So they put the lambda expression as the first argument because they think that you won't pass the lambda expression around. But in some cases you do need that, and what you could do is to write just a function that changes the order of the arguments. So, and just by writing the function AB equals the function that you want to call BA, you just did that, and you could change that if you want.
So just to recap, that
Yeah.
map function on an option, either if the input is a none, it'll
Yeah.
return a none, and if it's a sum, then it'll return the value as a sum,
So yeah,
or whatever is in there.
if this is a sum, it's going to extract the number from there.
Yep.
It's going to call whatever was the lambda expression that you defined there,
Yes.
and then it will get the result from that lambda expression and will wrap it in a sum option.
Okay.
Whenever you pass a none, it doesn't make sense to call this anymore. So it will return a none. And you don't need the if condition. That's why this condition that you have here, that is like an if condition, is much more fancier, but it's an if condition. And what you have here is like you get everything in one line, because this guy, it will automatically return none for you. Yeah, you don't need to match that. So now let's go to the latest version that we have, in which we have two pattern matchings. And now both of them are options. So the first thing that everybody thinks, and I thought, is I will use two maps, yes? And that will will solve the problem. So we could use option.map the same way that we were using before for this second case. But still we need to fix this other case. So this is, again, checking the last piece where we check if number 2 is none or not. But we need to fix the first pattern matching. And there is a problem with that. And it's because of the type that we get when we use option.map. And you will see this. Just try to think first about the two. We have this second function that is called option.bind. That is the one that we will need to use. But I want you to understand why we need this. If you check, the types are very similar. The only difference is that in the second one, the one that bind, it is actually expecting a function that returns an option as a result. Yes? And let's see what is that. What is the difference? So we say that the option map expects these two things, and it will return sum of two. The option.bind actually expects a lambda expression that returns as a result something that is an option type. This guy is returning an integer. This guy is returning the sum of an integer. And that's the only difference. Yeah? Both guys are returning sum in the same set. But if you think about, this is actually what the option map is returning. Option map is not returning the integer. It's returning now sum of the integer. So you could not wrap map inside map, because by using map, you broke the signature of the function. Yes, because now the function is not returning an integer anymore. It's returning sum. And that's why bind is useful, because bind is actually expecting a lambda expression or function that would return sum. And that's what this guy is doing. So how do we fix this? And this is going to get a bit confusing, but you will get there with time and practice. I'm still struggling a bit. This is how that looks. So we have map as we had before, and now we wrap the entire code that we had before using bind. And the last parameter, so we have number 2 here, that was the parameter that we passed here. From here you could see is actually this code, and that code is exactly the same. But now we wrap this as the first argument of bind, and the last argument that we pass is the other parameter. And you could also write this in this way, by using the pipeline operator, and just take number 1 from back there, put it up here, and then passing num2 from there, put it here, and it reads a bit better. So we went from this code to that code, just checking both option types, and that piece of code is translated to the option.map that you see there, while the entire pattern matching, the main one, is translated to the option.map. Yes?
I'm just going backwards. You know, having the match N1 with, can you actually, in the match statement, can you have tuples? Can you make it like a match N1 and N2?
Here,
What I'm thinking of, like, is can you treat N1 and N2 together as a single element?
Yeah.
So that way you can match N1 and N2, and in the case statement you'll have none and none, or sorry, none and some and none,
yeah,
and then some and some.
yeah.
Can you do that?
Yeah, you could. Yeah. The thing, so if you are going for the pattern matching option, yeah, you could have a tuple, and then you could use tuple so you could create a pattern that is a tuple that expects as the first argument to be none and the second one to be sum of the integer, and the other way around, and all the different combinations that you want. What you won't be able to use in that case is this one, because now you are operating with tuples and not with options. So the option.bind expects you, and the option.map expects you to work with options.
But with the, I mean, what I'm saying is you still have some N1, N2, but in the match statement,
Yeah.
treat it like.
So if you decompose that, you will end up having a code similar to that, because now you have the options and you need to check what happens in this case.
Well, that's what I mean, because in the match statement, in the thing, it'll be like, instead of like you've got none, which only just matches for one element, you could have the pattern match saying none, comma, I don't know how tuples work, or how you, could you say like n, what do tuples work? Just
a comma. Yeah, so you're right. So what you can do is go match N1, comma N2. And then you can match on none,
comma none, or whatever.
Yeah, and then you can go on none, comma underscore, which means don't care. None and anything. And then underscore, comma none, which is don't care and none. So that gives you all your none options. And then you could just go add some plus.
I guess from a readability
So
point of view.
that's right. And I think what we're looking at here, sorry to jump up, is that there's tons of power in option. We're applying, we could solve the sum N1 and N2 much simpler, but we're looking really here at the power of options. So while we could solve this exact problem simply, I can see
the use of signs and
but
maps.
you're right. In that, with your example, you will end up having a match here, a pattern matching here with three options. Yeah. So you would have, like he said, none and underscore and none, and then the one that had both values, and in that case you do the
Where it comes up, mine comes up as a more general mechanism. It's pretty trivial in option. But a more general mechanism is taking a message out of an envelope, like taking the value out of the option, working with the value, and then you stick it back in the envelope, which is basically the mode add.
So this bind is actually what is called a monad. So, but that's probably a topic for another session. We need to understand it first and then talk about that. But here we are using the monad pattern for that. In F#, in any place where you see bind, is a monad pattern. So I think that's pretty much all. Let's go write some code so you could try to understand this.
Sorry for ruining the surprise there.
No. So we will write this, and the first thing that we will do is to change that. So in this case, we will do value 1, and 2 will be passed to the option of map, and then we will have a function that will receive the value 2 and that, and then we will do value 1 that's value 2. So with that, we could get rid of this second pattern matching, and this is still going to give me the same signature as before, and then you run this and you get none. We put sum of 2, we will get sum of 3. And now we need to get rid of the other guys. So in order to do that, what we do is write N1, and we will pass that to option.bind in this case, and this is going to receive a lambda expression, that will be the value 1. And this guy is going to actually inside call this other guy. So now you wrap everything there, you get the same signature, and you get the same result.